Hi, I'm Conrad Twissel,
I'm Brian Capizzoli.
And Anglo.
and we're ABC Engineering Solutions. So we designed a BRG project, a Battle Frog Rube Goldberg project, in order to help physics students in high school better understand certain concepts. We went through a specific design process to make sure that we were doing everything we needed to do to make our company successful. We started with the planning process. We started with multiple proposed designs that we could try and figure out which was the best possible design that we could use. We created a mission statement for our company that makes sure we follow certain goals. Through raw data from interviews, we were able to figure out our customer needs and focus on certain things for our project that we wanted to make sure was in the final product. When we were going through our product specifications, we made a QFD chart in order to fully understand how our customer needs interacted with different aspects of our project. We did an economic analysis, which included benchmarking of similar products that allowed us to figure out a price point for us to sell our product at. So our original design concepts included 4 main design concepts. 2 of them included a conveyor belt that's going to be run by the Arduino board, which includes coding, and then 2 different types of ramps. Our other 2 designs were quite different. We used a pulley system that would hoist the ping pong ball up to a ramp and then drop it. And then there would be a rotating style gate that would drop the ball onto a spring-loaded gate that would propel the ball forward into the next part of the project. When we were going through our different design concepts, we realized that the spring-loaded with the rotating gate wasn't very feasible because it would be too inconsistent and it probably wouldn't work too often. The pulley system was we couldn't figure out certain parts of the design that were going to make the ball drop properly and be picked up properly. So we focused more on the conveyor belt designs. We ended up choosing the first conveyor belt design because we realized it's going to be very repeatable. It'll be very consistent in terms of being able to drop the ping pong ball, and it includes enough physics concepts that the kids will be able to learn, have a lot of physical application of the theoretical physics concepts that they learned in class. They'd be able to go through gear ratios when they're controlling the speed of the conveyor belt with the Arduino board. They'll be able to go through kinetic energy, and they'll be able to work through Newton's laws to calculate all of the things that they need to calculate. For our mission statement, we wanted to give students the opportunity to better understand the physics concepts that they learn in class, and we wanted to give them a physical application for the theoretical ideas that they learn. Our key business goals include our main goal was that we wanted to get a high quality product while keeping costs down, while still being user friendly and making sure we fit our target age. Our primary markets and our secondary markets were pretty similar. The primary market was high school physics departments. Our secondary markets were going to be any students or teachers inside these physics classes that want to purchase the product on their own and work on it on their own, but also companies and businesses that specialize in supplying scholarly tools for children, teachers, anyone in academia that wants to possibly work with this. The assumptions that we had was an age range of 16 to 18 because it's going to be students at junior or senior year of high school. We also were assuming that everything was designed and produced in-house by our teams. And then the stakeholders that we focused on was our team because our company is going to benefit or not benefit from the product specifically. And VTEPS Inc. because they're our parent company investing in us, and our customers and our users. For a customer profile, we basically just focused on students who we thought of when we thought of our high school physics classes. 17-year-old student lives with parents, doesn't really have much of an income. Most of their money that they're going to be spending is going to be from their parents based on need. So we definitely want to keep the price down because it's not someone with a big income. Attributes of this kid is just going to be typical high school student, athletic, probably in some clubs. Usually if there's a kid in physics in high school, he's going to be pretty involved in academia. He's definitely going to be focused on his school, so he's always going to put that first.
So for our use case, we have the basic flow of our design is the customer wants to have the speed of the ball be 3.5 miles per hour or 3.4 miles per hour when it leaves the ramp. So to do this, they're going to use laws of conservation of energy, and they're going to make calculations to determine how high the ramp needs to be and the angle it needs to be at and the length of the ramp and everything. So there's two flows that are going to happen. There's either the ball will be too slow when it exits the ramp, or it'll be too fast when it exits the ramp. So based on that, they'll have to go back, look at what's wrong, and adjust the height of the ramp accordingly to either increase or reduce the amount of potential energy that the ball has when it exits. The business rules we have, the customer is going to use all the supplies we supply. They're going to use the Arduino, they're going to make the conveyor belt system, and the ramp that we supply, and use those to make the ball exit with the post condition of 3.4 miles per hour. Here's our Gantt chart. As you can see, we have our critical path, but there are three tasks in particular. The intellectual property literature search, concept testing, and economic analysis. These three tasks are paralleled. That way we can adjust the length of them together, either increasing or decreasing the amount of time we spend on them based on how our other tasks go and if we're able to meet the deadlines with those. For our customer needs, we were able to interpret some raw data from the interviews, such as needs to visually demonstrate physics concepts. The interpretive need we got from that was we use physics to calculate the length and angle of the ramp to be able to actually control the speed of the ball. There needs to be they need to be able to store the entire assembly. So the assembly needs to be conveniently and efficiently packed together. So after use, it's able to be taken apart and stored in a classroom where it doesn't take up a lot of space. For our QFD, this is where we have our interpreted customer needs along with our specifications. And in this, we were able to determine what specifications correlated to which customer needs, such as the focus of physics topics was strongly correlated to the number of topics that we focused on. And through this, we were able to determine which specifications and customer needs were the most important and what we need to focus most of our time on.
This is the Star Coaster, which is one of our competitive products on the market right now. As you can see, it has a very good design. It looks interesting to the customer. However, it doesn't cover physics concept, as well as there's no calculation or programming that the customer need to make during using the product. On the other hand, our product covers all the physics concept and involve Arduino programming. Therefore, we think our product is a very competitive one on the market right now. For economic analysis, our fixed cost will be $10,000 a year. It costs $40 to build one kit, and for our price, it will be $100, and the price will be lower by 10 cents with every product that our customer purchase. Our maximum profit achieved at when we sell 450 units, and the maximum profit will be $10,000. To sum up, we use different tools to come up with the best product as we can. We do economic analysis to make sure that our products is profitable to the company, and we take advice from customer to develop our product so that it will most closely meet the customer needs. We compare our product to other products on the market to make sure it is competitive. And finally, we are working with prototyping to make sure that our product functions properly.